let's say the mass is 20 grams. And with a different technique, you also measure its volume. Now that you have both mass and volume, you can calculate the density for that. For example, you will say, I have 20 grams. Note that I'm using different unit. I'm not using kilogram because the sample I am dealing is much smaller than kilogram size. And obviously the volume is not going to be in cubic meter. So to simplify my calculations, I'm going with different units, cubic centimeter instead of. So 20 grams per 2.4 cubic centimeter. So if you do the math, you may get a number, which is going to be your density. So obviously this is one way to measure density. And the question comes, what if I made a mistake by either weighing my mass or volume? Then obviously I will have a wrong density. To avoid this, we are using a different techniques. We are not doing this experiment only once. We are performing multiple experiments. So after doing the first measurement, you do another one. You get 32 grams for 3.8. So this is another data for the same type of material. In a different experiment, you do 40, which basically comes to volume of 4.8 cubic centimeter. You do another one and another one. How is this going to be helpful for me? Instead of doing one experiment, I perform 5 experiments, and I'm explaining that again in the whiteboard for you. Let me actually use it here. So what I'm going to do is that we agreed that density is mass over volume. I can rephrase this equation in this form. I can write that mass is equal to density times volume. Okay. In your algebra, you're familiar with equations such as y, which is equal to a times x plus y. Generally speaking, you can draw that equation into a graph, which will be y will be this axis, x will be this axis. And since this is linear, it will look like that. This is the general situation. So obviously for this line, you have a slope. For those who already know calculus, they know the slope is, or trigonometry, they know the angle of this is alpha, and tangent alpha is equal to A. But for us who don't know trigonometry, we already know that slope is rise over there. So we can get a slope from here. Now I want you to compare what I just showed you as this graph to this graph. I'm drawing a graph. My y-axis here is going to be mass, which is measured. My x-axis is going to be mass volume here. And I can make a graph. If I compare these two, we said y is m mass. We also said x is volume. So by comparing these, you know that your slope should be density. And one more important factor to note is that in our particular experiment where we are doing mass and volume, we don't have any y-intercept, which physically makes sense. If you have 0 volume, you won't have any mass associated with that. So one of the points that we are sure about that, and we don't have any doubt, is this point. And then based on your experiment, you find, for example, the first point, you find the second point, you find the third point, fourth, and fifth. These are the 5 points that I have measured in this experiment, plus my y-intercept, which is 0. And then I draw the best line, which is passing through these points by fitting. This is something that your lab instructor later will teach you how to do with Excel. But this line is basically eliminating some systematic and non-systematic errors that you have with measuring, and gives you an average volume based on what you have. And the slope of this line is going to represent your density. So in this particular experiment, this is the graph which is drawn. And the slope of this line is 8.38. So we know the density is going to be 8.38. Here I have an example for solving a problem. We have an object which weighs 3.15 grams, and it displaces water by 0.233 cubic centimeter. The idea is that it's irregular shape. It looks like this, for example. So it's not easy to calculate the volume. You need to measure the volume. How you do it? You take a graduated cylinder. You pour some water on that. Let's say you have 10 cubic centimeter. And when you drop the object in it, it goes from 10 to 10.233. By dropping that object in here, the level goes up, and you measure this added volume, which is related to this volume, basically. So we know the mass, we know the volume, we can solve the problem and get the density of the object we are interested in. So we have the mass in a given unit, you have the volume in given unit, you get the density, which is 13.5 grams per cubic centimeter for this particular case. And you basically determine the density of this object. Okay. After knowing this, I'm going to show you some of the points about measurements. So this is a graduated cylinder I was talking about. So you can see that this graduated cylinder is divided to different sections. So we have a major line, such as this guy and this guy. And this guy. The major grades that you have is based on 1 milliliter, or 1 cubic centimeter. You also have subdivisions. The subdivisions you have are shown by those little lines, such as this guy, for example, and this guy. The separation between them is 0.1 milliliter. So if I want to report the volume of water in my graduated cylinder, I focus on the meniscus, which is located here. The bottom of the lens which is formed. So clearly you see that it happens somewhere between 4.5 and 4.6, right? So 4.5 and 4.6 is the ones that you are certain about them. So your device is graduated based on 0.1 milliliter. Anything after this digit is going to be based on guesstimation. You are allowed in any measurement to guesstimate one more digit, and you should do it. So for example, what I know here is that my number is somewhere between 4.5 and 4.6. I'm allowed to say 4.53, 4.58, 4.59, 4.51, anything. I'm allowed to do it. But I'm not allowed to say, for example, 4.5, because I missed the opportunity to guesstimate one more digit. Or I'm not allowed to say, for example, 4.583, because now I'm reporting one extra digit for which I have no way to argue. So basically, this is how we are reading these devices. And in this particular case, the correct answer based on the choices we have is only 4.57, because 4.5, we didn't use the right number of digits. 4.44 is not correct. It has to be between 4.5 and 4.6. 4.5.4 is also wrong. And 4.57 is the only option which makes sense. One more thing I need to say about measurements: when you're measuring things, there are two types of quantities. Some quantities relate on the amount of sample. So for example, when you are talking about mass, so depending on how much material you have in your sample, you will have different mass. So it depends on the amount. So those things, we call them extensive properties. Intensive properties are the ones which are not related to amount of to the amount of sample. For instance, when I'm talking about water, I say density of water is 1 gram per cubic centimeter. It doesn't matter if it's 1 tons of water, or if it's 1 kilograms of water, or if it is 0.001 gram of water. The density of water, independent of the amount of water, is 1 gram per cubic centimeter. And those type of properties, we call them intensive properties. Next time, I'm going to talk about unit conversions for you.